Good morning. My name is John Dennis and I'm chairman of the International Lean Six Sigma Institute, and I'm your presenter for today's straight talk about process control, statistical process control, real-time statistical process control, and a product called Datalyzer, which will help you and your company to control your processes. Our guests today are Paul Allen of Allen and Partners based in Cardiff, Wales. And Paul has over 25 years experience in manufacturing and is a world-renowned expert in design of experiments and in statistical process control. His latest book is called DOE for Engineers, Design of Experiments for Engineers. Welcome, Paul.
Morning, everyone.
And it's my great pleasure to welcome Stephen Murphy, who has been working with and associated with Datalyzer for the past 10 years. And Stephen is also in Wales at the moment, in Wrexham, is that correct? Or yeah, okay. I think Stephen's just frozen a little bit there. Has your camera frozen, Steve? Yeah. Stephen's in Wrexham, and we're going to hear a little bit about Datalyzer. Now, as I say, we're going to have straight talk in this presentation. We're going to try to cut through a lot of the uncertainty, the nonsense, the acronyms that are used, because people that are watching this may not be familiar with process control. So we're going to start at the very beginning. And my first question is to Paul Allen. And for those people out there that are just new to perhaps process improvement, Paul, what would you say is process control, and why is process control important to businesses to understand and use?
Okay, so to keep it simple, if you think that the data that comes out of your process is a big random number generator. And of course, one of the problems with a random number generator, you don't really know what's coming next. So if you think about a random number generator that we would understand very simply, a six-sided dice. So if I was playing with a six-sided dice, we would all know the numbers that we expect from that process. And so if I happen to roll a 7, you would immediately go, whoa, hang on, there's something wrong. Now, why do we know there's something wrong? It's because we understand the process. We understand its limits, 1 to 6. We understand that it has a pattern, so we know we're expecting equal quantities of all the numbers. And we also know it's got an average. It's got an average of 3.5, because you can't roll 3.5, but we know where it's sitting. So we know its pattern. That's the important thing. We know its behavior. And really what SPC is, the best phrase I like is that it's about process behavior.
Process behavior.
Yeah, and if you call them process behavior charts, that's almost a better phrase than a statistical process control chart.
Very good.
You know, so you're trying to understand the natural behavior. Now, a dice, we understand it. But
Yes.
because your own process, you don't know what the limits are. You don't know what its average is. So all you're doing, you're taking a picture. What's natural to this process? And if it does something strange, then you investigate, because your machine is screaming for help. And that's really what the technique is, understanding the natural behavior and when your process is behaving unnaturally.
Very good. So the first thing is to understand what is natural to your process, understand the process, then you can know if something wrong is happening.
Yes.
And what you're saying is that unless we know what is normal, we can't know what is not normal or usual.
Yes. And the worst thing you can do to a process is interfere with it when it doesn't need interfering with. Because what you'll do, if you think about your six-sided dice, it's going to have a range of 1 to 6. So if you're trying to put tolerances around that, 1 to 6 is the best it's ever going to be.
Yes.
But if you grabbed hold of an adjustment and you started swinging the thing backwards and forwards, now it's going to go from 0 to 8. Now, why is it going to go from 0 to 8? Because you're swinging on a dial and making it worse. So one of the things SPC makes you do is to sit back, drink tea, and read the paper more. Leave your process alone. Because it'll behave much better if you don't interfere with it.
Now, we're straight talk in this presentation, and you said SPC. So what does the statistical part mean? SPC means statistical process control. How does statistical process control differ from just process control? Where does the statistics come into it, Paul?
The statistics is that bit about understanding the natural behavior. So if you think of the statistics on a dice, it's got a range, 1 to 6.
Yes.
So that's its statistic. If you think of its average, it's got an average of 3.5. That's its statistic. Now you can get those numbers for your own process. If you collect some data, you can work out the range and you can work out the average. And there's the statistics that you're going to use to understand what's natural to your process.
It's something to do with understanding probability as well, Paul, isn't it? Is it not? That the statistics is to understand the probability that your process is going out of control.
Yeah, I mean, I use a dice because it's simple. Unlike a dice, your process doesn't have a uniform distribution.
Yes.
So obviously, the further you get into the more extreme results, the rarer those events get in a real process. So if you're trying to hit a tolerance and you have a nominal you're trying to hit, you've got the machine set on the nominal. The further you get from the nominal, the more rare that event's going to get.
Okay. I think by nominal, you mean target?
Yeah, target, John.
Target, yeah. And by tolerance, you mean what are acceptable limits?
Yeah, the limits that your customer wants
and the target. Yeah, just keeping it real. Just keeping it real.
That's okay, John. No, that's okay.
Good. I think that the statistics helps us with analyzing the measurements that we make in our process in order to try to understand its behavior. The average, for example, and the variation. We use statistical measures to both measure and calculate those numbers. So, Paul, I think you would agree that the calculation of an average is using statistics. Yes?
Yeah, absolutely. Yeah. I think we tend to worry about statistics and we tend to shy away from the statistics we don't understand. But every day people are calculating averages and then using them to make business decisions. Well, you're using statistics whether you like it or not. So, you might as well get good at it. Yeah,
thank you. Now, if I may ask Stephen, because I was talking to Stephen the other day, and Stephen, you mentioned that perhaps putting the word in statistics into the name of process control or relating it to statistics may be doing us a disadvantage or a disfavor because it seems to be more complicated than it actually is. And you mentioned it might just be better to call it process control. Oh,
yeah.
Stephen?
Yes, because
you're breaking up a bit there, Stephen. Yeah. Stephen, I think
it can be something.
Yeah, I think you're a bit frozen, right, Paul?
Yeah, I'm not getting you, Steve.
I'm not getting your feed. It was working fine before we started the call, of course. So, Paul, yes, I like.
Can you hear me now?
Yes, I can hear you now.
So my point is that think about it as more like process control. You might need to get some help with the statistics to set the thing up in the first place. But once you've got it up and running, think about process control. Think about when it gives you a signal, you need to go and do something to bring your process back under control. And that is the real key point for manufacturing and business people. It's not the statistics. It's the fact that you're bringing your process back to being as good as it is capable of being. And that's what you need and your customers need. Get a bit of help with the stats from your local experts.
Yeah, yeah. And I think when we say control, we are talking about stability. We want stability. Is that a good synonym for control? That the process is stable?
Exactly. We don't want the average of the process moving all over the place, and we don't want the range of the process moving all over the place. So we don't want, in Paul Allen's terms, we don't want the dice to suddenly move from have an average of 3.5 to have an average of 5, or we don't want the range of numbers that the dice is giving us to suddenly go from 1 to 6 to go from 3 to 9.
Yeah.
So we want to keep it where it always behaves. So that is the goal.
So we want it stable. We want it predictable. We want to understand the behavior so that we are alerted when the behavior changes from what is usual.
Exactly.
Now, Stephen, how would Datalyzer help us to know when the process has changed from its usual normal character to something that's different? And what sorts of alerts or signals does Datalyzer give you?
The real thing, the great benefit of Datalyzer is to help you to run your processes within manufacturing when you have more than a couple of processes. The real benefit is it is a management system. So at the first level, the first level operators may be putting the data in, it may be collected automatically from a machine, but they'll get a signal. And a system Datalyzer will provide you with what's called an OCAP, an out of control action plan. So if the operator gets a signal, there's something they can do at a first level to make some investigations and to bring the process back to normal. Okay. But it doesn't just end with the operator. A system like Datalyzer then allows routine reporting, so the shift supervisor can see what's in control, what's out of control on my shift. The engineering manager can then look at the data from hundreds of processes and say, yep, all 100, they're all well in control over the last week. We've got 3 out of controls and the people have dealt with them. The senior management can then look at the summary for the whole site and say what's in control, what's out of control, how are you driving improvement.
Okay. Systems
like Datalyzer will also send you a message. So if a point goes out of control, if for some reason this piece of machinery is crucial to the organization, it will send a mail to a list of people. It will send a mail to the chairman of the board if you want. Maybe you'd prefer that he doesn't know, but it will do it. So what I'm saying is that basically systems like Datalyzer allow you to put all the communication and all the information delivery done automatically, so that you can then spend your time improving your processes.
And when is this email sent? In what time frame is this email sent, Stephen?
About 4 nanoseconds after the point goes out of control. It's immediate. So it's not summarized. It's sent out immediately.
It's sent out immediately. So this is a real-time process control management system.
Exactly. And the key thing about it is as the variation occurs, the system picks it up. It can send out, as I said, it'll send out an email. You can make it drive an and-on light. You can
so lights, buzzers. I mean, it could any type of visual signal, but then
you're saying there's a signal comes out there, so that you can use it to drive an and-on light if you want.
Okay.
And Mark Schaefer has written quite an extensive paper that you'll see under the Datalyzer white papers on the use of an and-on light. When an operator maybe has several processes to deal with, and they want to be able to see if one goes out of control.
Okay. Now, are you still seeing people being paid as operators that are in control rooms and visually monitoring the Datalyzer screens, or are they doing something else and they get alerted with their phone or their pager? I know, some sort of buzzer. But are you seeing the traditional type of operator still exists, where they sit in the room watching for something to happen?
Just basically, one of the key things about Datalyzer is that we will provide the customer with what the customer wants and is appropriate for their circumstances. So we've got people who the operators put the data in and take a quick look at the chart themselves. We've got people who sit in using big data applications where big data transforms the data from hundreds of charts into a big operating center. So basically, an offline operating center is watching hundreds of charts from a particular production line. So we've got and everything in between. So if they need a text message, we can use a text message system.
Okay.
If they want a phone call, an email.
Yeah.
I can't think of anything that we haven't done. Datalyzer has been in the business for 40 years. And
40 years. Yeah,
40 years since we implemented the first real-time SPC system. So, and basically it has got added to that functionality as times have changed. So now we've still got the traditional, almost computerized chart that the operator checks, but everything in between.
Okay, thank you. I think from some previous conversations with Paul, and by the way, Paul has an excellent YouTube channel with hundreds of videos explaining things like process control, Lean, and Six Sigma. If you just type in Paul Allen SPC, or Six Sigma rather, if you type in Paul Allen Six Sigma, you will find him. Now, Paul, you have some strong views on what operators should be doing in their control rooms.
Well, I mean, actually, Stephen described it quite well in terms of having a system. You've got to have a system of action, but it's got to start with the operator. So people misunderstand that the chart is for the management, whereas really the chart starts as it's an operator's tool, and they should be the first port of call. And Stephen described it really well. You know, it's too easy to put the chart in, let it generate a signal, but you've not organized anything else behind it. And Stephen described it really well. You need an action plan. So you know, he described that thing at the top, out of control, the out of
action
control
plan.
Yeah. What do I do now? And this is a common problem where people they've tried to implement SPC, and one of the common problems is that they've not set up a system of work behind it. So they don't have an action plan. So when the operator gets the out of control symptom, he doesn't know what to do. Possibly the next data point, maybe the symptom goes away and he thinks, oh, okay, I'm done, I'm happy. And then maybe the symptom comes back again, you know. An hour.
Well, are there some basic rules that might have been established for when an operator should pay attention and potentially act, and when they should just do nothing? Because you're a big proponent, I believe, of not tampering with the process if it is not out of control. So what are some of the basic rules, either Stephen or Paul, that we can use to help us to decide whether to take action? And is this built into the software?
I'll let Stephen answer.
Yeah. The basic rules are built into the software. So all the rules that you will see in the offline packages are built into Datalyzer. So there's one thing that is, and this is what I would say to people to start with, is just implement this rule, and this is called X bar plus 3 sigma.
Yeah.
So what it means by this is, let's not worry about what sigma is. Let's just think that if one of your points goes out with this magic X bar plus or minus 3 sigma,
Yeah.
then that will only happen by chance, maybe 1-2 times in 1,000. So that says it's very unlikely to be chance. That gives you a signal to go in and investigate. There are other rules that say, well, has the process suddenly jumped?
Sorry, you broke up there a bit, Stephen. Stephen, while we're waiting for Stephen to get back,
I'll step in if you like, John.
You go ahead, please.
Yeah. So yeah, I mean, Stephen was just articulating other rules. So again, if we keep it simple and go back to a dice, if I was rolling the dice here in front of the group and I kept rolling 1s, 2s, and 3s, ultimately the pattern is being violated. I haven't stepped outside of the window that you expect, but you know, you don't expect there to be constantly 1s, 2s, and 3s being rolled on a 6-sided dice. That would be a sign something's wrong. And of course, ultimately, the average would fall below 3.5 if that was the case. Okay.
So what sort of categories do we have in something that is behaving abnormally? We, as Paul said, we sometimes have patterns of data that show something is out of control. Yeah. And what are some of the patterns you might be looking for?
Well, I mean, typically, you know, being constantly above or below an average, that's unusual.
Yeah.
The other one, of course, is going for a run. You know, if you rolled a dice and you went 1, 2, 3, 4, 5, 6,
yeah,
especially if it kept going 7, 8, 9,
yeah,
that would be very unusual for a random number generator.
Yeah, a run up or a run down.
Or a run down, yeah. I mean, the game show that I referred to, John, is play your cards right. You know, when they give you a 2 and what do you say? You say higher. Then they give you a 5 and what do you say? You say higher. And eventually they give you a queen. And what do you say when they give you a queen? You say lower. And if it keeps going in that direction, that's not a random pattern. It's not a pattern that we would usually expect. And that's what you're looking for. It's patterns that you don't usually expect. Go ahead, Steve.
And I think these patterns were first investigated and really recorded or talked about, published. I mean, they'd always existed, but they were first recognized. That's the word I was looking for. They were first recognized and documented back in the 1920s and 30s, or even earlier than that.
Yeah, I think it probably was Walter Stewart. Yeah.
It was the start of scientific thinking about process control. And I think Walter Stewart gets a lot of credit for that. But whenever you mention people's names, as you know, other people have other ideas about who we should give credit to.
Yeah.
So I think there were a lot of people involved, and 1 or 2 people got credit. But I would have a hard time thinking that people that were setting up, for example, the Ford assembly line in Michigan in 1903, 1907, did not know something about what sort of behavior to expect and what was unusual behavior, right? So I think it goes back a long way.
Yeah. I would say that Datalyzer will you can turn all these rules on that Paul's talking about. You can turn them on in Datalyzer.
Right.
So as your knowledge of your processes gets better and better, you might want to detect smaller and smaller changes, so you can turn all these rules on. I just wouldn't recommend it in the first place.
Okay.
If you do it in the first place, you'll probably find your poor operators losing the last remnants of their hair.
Okay.
But just look for the real big jumps to start with.
Now,
and fix those.
Good. You've mentioned the word charts a few times. Charts, right? So charts is some sort of visual representation of the process. And what sort of charts, what are some of the names of the types of charts you might be using in process control that the listeners and viewers might be familiar with?
Your classic is almost your standard, is your X bar R chart. And this is derived by taking a smallish sample, maybe 5 to 10 points in your process, working out the average of that sample and the range of that sample as per Paul's dice. And you put the X bar on one chart or one graph, so one point after the other, and the associated range goes underneath it.
Right.
You use there will be the limits will be mapped on that chart, and those limits will be based on, as Paul says, the natural variation from historical data.
Just to take a step back, Stephen, for those that are not familiar with the phrase X bar or R, I think out of the charts, the most common type of chart is called the control chart. Yeah.
Oh, okay. Yeah.
So we have the control chart, and that has a particular look to it, doesn't it? It's tracking points. It's tracking points over time.
Yeah.
Right. So you get a pattern of points over time, right? And this is your variable that you're measuring here. Right now, what other types of, that's not the only way to know whether your process is under control. What other things might you be looking at? What other types of charts might you have on your dashboard, for example? Or what sort of charts does Datalyzer do as well as control charts?
Well, the other thing is it will do control charts for both continuous and attribute data. So this might take a little bit more explanation. And continuous data is where you're just making a measurement, and that, if you're expecting the number to lie between 1 and 2, it can take any value between 1 and 2.
Yeah, data types.
Yeah,
Paul.
attribute data is like when you're measuring defects. So you're picking up at a piece and seeing how many defects are on it, and you either have 0 defects, 1 defect, 2 defects, 3 defects, or you might be taking a sample of pieces and saying to yourself, well, how many defect pieces do I have in this sample I've taken? If you were taking samples of screws out of a big batch of screws, maybe.
Yes.
So Datalyzer will deal with both of those types of data.
Okay. Are we only talking about this type of control chart for control? Are there any other types of control visuals we can use?
I don't totally understand your question. I'm
just wondering if it's worth seeing the shape of the data. It's difficult to see the shape of the data here. Something like a histogram of the data will give you an idea of the shape. Is that useful at all? So, a histogram looking at where our last, 100 points are.
Well, I usually find those sort of charts more useful when you're going into the analysis of failures, and you want to see the shape of the data. So does it normally look like a normal bell curve?
Yeah.
If you look at it over it, or does it suddenly develop a great big tail on it?
Yeah.
So Datalyzer, the new Qualis system, does have the ability for the operators to pull up the histogram chart.
Okay.
So if they start to make some investigations, they can look at the histogram of the data from their screens.
Now for somebody that might not be very good at interpreting charts, are there any numbers that are displayed that are a summary of whether something is in control? maybe you just have, or colors. Maybe does it change color just from red to green when it goes out of control? Or do you have to actually understand the control chart? Paul?
Well, I mean, normally the charts that I'm using, I'm a big fan of doing it by hand. So I'm quite old fashioned in that respect, simply because I want people to understand it, first of all, and I want them to look at the diagram. So normally we're using those rules that we talk about. But I take Stephen's point. I tend to wind those rules down. So I will get people to just use maybe one rule, maybe two. The other thing I've done in the past, I've just got them to plot a graph. I mean, I've given a graph to an operator and I've just said to him, I'll be back in 4 or 5 weeks. Can you do me a favor? Will you just plot a graph of the data that you're collecting? And I let him just collect the data, plot a graph, and I let him look at it himself. And when I came back 5 weeks later, I said, oh, what do you think of the graph? And he looked at me and he said, I was making it worse, wasn't I? And I said, I don't know. He said, yeah. He said, once I plotted the graph, he said, I was swinging on the dial and I was making the bloody thing swing around all over the place. He said, I took my hands off and he said, process works much better. So, you know, but once you've got that understanding, then you can go to something like the Datalyzer where you go, right, we value this, we understand it. Now let's make it more efficient. Let's make it work much better. And then you can go to the, you know, because otherwise you're getting the signals and nobody knows what the signal means.
Oh.
You know, partly because sometimes the signal isn't related to a tolerance. So it's not telling you you're out of tolerance. It's telling you you're out of control.
Right.
It's a completely different thing.
Yeah.
And if something's not out of tolerance and somebody gets a red light just bleeping at them, they'll go, yeah, but it's not out of tolerance. But, you know, think about the dice again. If our tolerances were 0 to 8, we were rolling our 6-sided dice, it's happily performing inside our specification. If the dice suddenly rolled a 7, that would be a very unusual thing. We'd have to investigate that. We've got to do something. The machine is screaming for help. But because it's inside the tolerance, the operator might go, it's okay, I'll leave it. And then your machine breaks down because you didn't investigate a simple oil leak or whatever the problem was. So, you know, that I'm a fan of doing it by hand first, understanding what you're doing. Then we can go to the electronic tools. But you could use one of the tools, you know, you were asking about other techniques, John. You could use something called pre-control, where they use red and green and yellow zones on the chart. Again, I'm not always a fan of it.
Okay.
But it's, you know, for me, I'm a practical guy. I'm a fan of anything that makes your process work better. So, so if you use a technique and it makes your process work better, it makes you understand what control is.
Yeah.
It gives you signals for action planning. Then that's good. That's good for me. You know, I'm not going to be pedantic about particular tools and techniques.
Okay.
Yeah,
you mentioned the word signal. I just, for the people that are out there that may not be familiar with the use of that word, I think we do have to be careful with the word signal because within process control, signal can mean different things. And I think you were using the word signal there as the alert that something is wrong, the signal that something is going wrong.
Yeah.
Right. But we can also use the word signal as actually meaning where the mean average is. Is that not correct?
Yeah, that's a good point. Yeah, what we're talking about is your process isn't behaving like it did yesterday. So if we think about process behavior, you take a picture, here's how my process behaves, this is what I expect it to do. If it starts doing something that's unusual, that's a signal to go and investigate.
Yeah, it can be confusing when people use the word signal because we also have the idea of signal and noise, where the signal is the average and the noise is the variation. So we have to be careful with that. Next question, Paul. You were mentioning about doing this by hand and understanding how it's constructed before you use software.
Yeah.
Now, everybody used to do it by hand, or they'd use slide rules to calculate things like averages and standard deviations. Where are you on the idea of calculating control limits using formulas and using tables? Where are you? Where do you sit on that, Paul?
I have to say, if I'm going to calculate the limits, I'll use the software. I do it electronically when I'm calculating the limits.
You heard this from Paul Allen. Use the software to calculate your control limits because the calculations are built into the software. Okay. Yeah. So give me some examples of software you could use as an alternative to Datalyzer. Paul?
I use something called SPC Excel.
SPC Excel?
Yeah. I mean, it's very good because one of the things it will do, you can put the data in, calculate the limits. And then if you like it as an electronic tool, you can just keep adding to the data set and it doesn't recalculate the limits. So it's updating the chart and it does kind of what Stephen says, which it does some out of control checking for you and things like that.
Right.
It's very basic. It's not going to do anything that's...
It works with Excel, yeah? It works with Microsoft Excel.
That's right. It's an Excel add-in. It doesn't do anything that Stephen's software does, like send emails or anything.
Because
like
it's
that.
not real time.
Which is an escalation, it's an escalation process. But, if you want to dip your toe in the water and get used to, one, calculating the limits, and two, doing it electronically, it's a case of get some value. Get to the point where you love using this and it makes money for you. Okay. And then when it makes money for you, then you can make it super efficient and fantastic and you can get everything out of it. But if you don't love it, you can have the best software in the world and nobody will look at it.
Okay. Stephen, how does your software differentiate itself from things like SPC Excel and Sigma Excel and Minitab, I believe, is one of the other big softwares for process control? How does Datalyzer differentiate itself?
It's a real, the key thing about it is it's a real-time system that has all the management tools added to it.
Yes.
So it will give the first level operators that signal that something's happened. But then you can add all the management reporting to it so that there are visual displays so that the actual supervisor can look at all his machines at once. And if the big pile of squares are green, all his machines are running. And if one of his squares goes red, he knows he's got a problem on one of his machines and he can go and look at it. So it allows the operator to do the management, the supervisor to do the management, the engineering managers to do the management the next day, reporting that goes all the way up to the senior management. We have 4 critical charts. Have they all been performing well over the last month?
Yeah.
When you've got lots of charts, it can be a real pain to say, are my limits still good? Are these the limits I should be using? So Datalyzer has systems whereby it could sanity check all the limits for your hundreds or thousands of charts with a standard report. And so every month, if you want, you can check the limits and say, yeah, those limits are still good for that report.
Yeah,
they're still good for these charts. So basically, it takes the grunt work. It helps you to do all the management you'd like to do if you've got tens and hundreds and thousands of charts. It helps you to do that really easily. And that means that things that wouldn't get done if you had to do it by hand get done. You spot problems quicker at all levels, but also the fact that it takes that grunt work away, it frees up the time. Instead of spending, when I was a lad, I used to print all the charts off and I'd calculate the limits. If I had 30 points, I'd measure it with my ruler, divide by 5 and multiply by 6. That's how I'd check the limits. I'd done it. So, but you don't have to do that. It takes 5 minutes in Datalyzer. So the 2 or 3 hours that I saved, I can now go and do some process improvement. So it takes the grunt work out of maintaining the system and allows you to drive improvements. And that is what they do. On a 1 chart level or 2 chart level, it does no more than your Excel add-ins. And these are great because, as Paul says, you can stick them on your desktop, you can play with them, you can calculate the limits all the time and see what happens. And they're easy to play with. But when you start to get hundreds and thousands of charts, which I have had in the past to be in charge of, you need some tools to help you to do it, and that's what Datalyzer brings.
Okay. Are you allowed to name drop some of the clients that have had success with Datalyzer, Stephen, and perhaps have used hundreds of thousands of points, and that
Datalyzer has 4,000 clients worldwide.
4,000 clients.
4,000, over 4,000. So you will have heard of some of them. I expect most of you have heard of Coca Cola. Yeah, Coca Cola.
Yeah.
If you go onto the Datalyzer channel on YouTube, you can see Datalyzer being used on a Coca Cola production line.
Okay.
Yeah, people like this, people like Coca Cola are very, very keen that they don't use too much plastic in their bottles.
Yeah.
If you use a gram too much plastic in 1 million bottles, it's a lot of plastic. So they keep all this stuff under control.
Okay.
You've got people like ST Microelectronics, all their back-end sites, just to make sure that the electric wires connecting the silicon chip to the outside world are stuck on properly.
Okay.
That is the sort of thing we do.
Great.
Micron Technologies, we have 20 Mars plants. Everybody knows Mars. 20 Mars plants use our software. So there are Ford, Bridgestone use our software. Not all of Ford, I don't think, but there are certain sites have used our software for a long time.
Mm. Do you have a competitor that is doing real-time SPC? Is it people like SAP that are trying to compete with you?
I think other people might be trying to move into it, but Datalyzer, with our 40 years experience and our basic focus has always been, what does the customer want? In other words, the improvements that are built into the system are really based on us talking to our customers over the decades. Okay. So that, yeah, there are other people will try, and there are some good players out there, but
okay.
But we have 40 years experience, and we've moved from effectively putting charts on a screen now to doing SPC on big data.
Lovely.
And the key thing for me, if I could just add this, is the system is so simple that I've got a couple of customers in Scotland who basically have the control software to set up the system and 2 or 3 terminals to put in the data. It is cost effective for small companies.
Yeah.
So that is its real strength as well, to my mind.
Great. Thank you very much. And Datalyzer.com is where you can find more information. I think you have some videos posted there, and you set up regular training classes as well for anybody that's interested.
Within the site, www.datalyzer.com, if you just go in and follow the obvious links at the top, there are links to training. So we have regular webinars. If you go under training, you'll see the regular webinars. If you go under training, you'll see that there's actually some free SPC training there, which uses our tool, the SPC Wizard. If you just download that free download, and you can use the self-training SPC system there. There's a whole stack of white papers that include that have included all the experience that we've built up over the years. You can also, if you want to have a play with the system, you can ask for a free demo. So just follow the links on the website, and you can get access to a free demo. Myself, either Charlene may well be, or Kim, or one of the other people with Datalyzer, more than happy to set up a Zoom with you, and we can show you how the system works.
Thank you.
So
Thank
in
you.
fact, over the lockdown, we really have, and before the lockdown even, we had a lot of experience in supporting people remotely. Over the lockdown, I think we've got even better and better helping people to install Datalyzer remotely. And the unfortunate thing about it, from somebody who provides training, is that what I find is that the real unfortunate thing is once you give people a head start nowadays, they are actually so software friendly, they are so software literate, they just get in there and they start asking me questions that I have to refer to higher authority, you know. So it is simple to use.
Okay, Stephen, we're going to take some questions now. I'll just cut you off there, I'm afraid. We're running a bit out of time. We've had a number of people shown an interest in this discussion through the LinkedIn forum, and we have a couple of people that have joined us live, but a lot of people will be watching this. We're recording this and going to be putting it on YouTube, so there'll be questions coming in there as well. Yeah, I know that we have Miguel on the call. If you were there, Miguel, who is in Portugal and has experience in manufacturing. Miguel, are you still there? And have you got your camera that you could turn on? Yeah. Looks like he's coming on. There he is. Yes. I know it says Alexandra, but it's
okay.
Somebody else is right.
I believe that you. I'm trying to connect the camera, but I believe that
I should
probably forbid it.
Sorry.
I'll try to. Okay.
Now all right. Sorry. Yeah.
With a nice coffee bar on the.
Yeah. On the back. Welcome. And Charlene is in Jersey, I believe, the Channel Islands, and she is working with Datalyzer. But I just wanted to. Miguel, thank you for staying with us. I just wanted to see if you had any questions or any points you'd like to make about process control, since we are honored to have you with us for the whole program.
I have process control for over more than 12 years on the road, working in ceramics and in the foundries. And like Paul said, it's first all about people and try to make them understand. If you don't go that path, things will have a lot of lights everywhere, and nobody can really check on the problems that are on the process what the process is being said. But I've in the meantime went to the Datalyzer website, and I've checked some things about nowadays Industry 4.0, Quality 4.0, and all of that buzzwords. And I believe that for Datalyzer and other companies, for us to keep the pace, we need to go into artificial intelligence for it to more or less help us understand and give us the summary of all of that signals, because putting a lot of data, a lot of things, even for Coca Cola, I believe there's an engineer somewhere on some people trying to understand something. And if there's a lot of inputs, it's very difficult, even on an SPC basis. Even if you go to preventive maintenance, that you can also have Fourier analysis and things like that, it's somewhere, I think it's difficult. I prefer the approach, keep it simple and stupid, and first understand it with the people, and like Mr. Paul said. And I think that it's very good, because I have experience in Industry 4.0 and having a lot of data coming in, and I'm telling you, people simply go blind. They don't have the capabilities to deal with all of that inputs, all of that outputs. It's really difficult.
I think I'd like Stephen to give a comment on that, because I believe Datalyzer has been thinking about this.
Yes. Couple of points. First of all, a bit of a sales pitch. I don't know, but we have a man in Portugal called Bruno.
Yeah.
So if you'd like to get in touch with him, if you could give me your email, I'll get you in touch with him.
Okay.
Secondly, Datalyzer is trying to move in this direction.
Yeah.
If you look, I think on the far left hand box, it talks about our strategic alliance, and I think the company is called Animation. Yeah. So Datalyzer is working with people who are working with big data, using SPC on big data, and trying and starting to go in this direction. Yeah. I suspect they probably have something within artificial intelligence as well. So if there is something specific that you want to know about, or have a particular application, it would be good to understand a specific question. But generally, I agree with what you're saying. Slowly but surely, we're going to have to go and learn how to use masses of data effectively. We've got there to a start, and you'll see the example by using combining SPC with big data, and
right.
That is taking data from PLCs, and the data is fed to a big control area, and it receives signals a bit like you get from a standard SPC chart.
Yeah,
I think the area is just developing.
I like Miguel's comment that people go blind when they have so much data and the analysis of what it means just can't be done. And I think Paul has talked about this before. He writes about it in some of his books. And I think, Paul, you're a big fan of understand what you can to the point where it makes sense. And if you try to push those limits, then you actually start going backwards somehow. You start losing control rather than gaining control.
Yeah, I mean the one thing that I'm always worried about with the big data discussion and the AI discussion is we have tools to understand the process, which are to me are relatively simple. I mean, I'm not a particularly academic person, you know. I'd be like Stevens, if he starts talking software to me, I gotta pass that off to somebody who knows what they're talking about. But so I like to keep my analytical techniques as simple as possible to understand the process. And those techniques are getting lost. So, you know, if you think about SPC has a set of rules to be able to understand the pattern. If you're going to do AI, those rules have to be in the software. Don't reinvent the technique, because if you think some flipping algorithm is going to understand the process better than what the SPC rules are going to understand, all you're going to do is the software is going to reinvent those flipping SPC rules, but it's going to be buried in software and you're not going to know it's doing it. So I always worry that, you know, we're going to go, oh, software's the answer. Let's throw all the logic. That's the important thing. There's logic in what we've learned. There's logic in SPC. There's logic in design of experiments, and there's logic which will always be valid. Yeah. You know, I mean, what our common colleague Gigi Anthony, who I love to meet and talk to, Gigi, we had a little conversation about whether the 7 quality tools were still valid.
Yeah.
And my view is very straightforward. Unless somebody's changed the physics, the 7 quality tools will always be valid.
Yeah.
And that would be the same with AI. Unless somebody's changed the physics, SPC will always be valid. Design of experiments will always be valid. Unless we go to a different planet with a completely different set of laws of physics, all of that stuff's valid. Let's make sure it's built in to any fancy software that we develop, and that would be my my personal view. I get a sense when I talk to the techies They don't even know what SPC is. They don't even know what DOE is. They're reinventing it all. I'm going, why would you do that?
Right.
You've got some beautiful techniques to understand what's going on. Build them into the software.
Yeah, very good. I've got one. We've got 2 minutes left because we've been on for an hour. I got a closing comment from Stephen Murphy. Then we'll go back to Miguel.
Okay, I generally say apart from rushing out and ordering Datalyzer immediately, the advice I'd give you is go with Donald Wheeler's Understanding Variation: The Key to Managing Chaos.
Yes.
Before you get into stacks and stacks of fancy statistics, this book will keep you on the straight and narrow, because the whole ethos is not how to be a professional statistician. It's how to use basic control charts to make money for your company. And that is that, and to reduce waste and improve customer satisfaction. And before you do anything else, get yourself a copy of Understanding Variation. In fact, you can pick it up on any of the book sites. Mine's a second-hand copy. It will probably be the best $2.95 postage you ever invested in your life.
Thank you very much. And have you got a copy of your book handy to hold up, Paul? Or that's Paul's book?
Paul's book there.
There's my book. I haven't got a copy of my book for some strange reason.
All right. Thank you. All right. Plug for that. Miguel, thank you as a guest. What were you going to say, please?
Yeah. Stephen, don't forget the tea with the book.
Yeah.
Don't forget the tea.
Read the paper.
Coffee.
Yeah, read the paper.
Yeah.
And I already read a lot of books of Dr. Donald Wheeler.
Yeah, he's very good.
He is very good. I second and third recommendation about Wheeler. Sometimes he knows the maths deeper than anybody, but most of the time he just puts it in straight English. Yeah. And it's just great. Really good.
It's very simple. His English is amazing. He explains things very simply.
Yeah.
But trying to make an end and make a point regarding what Paul said, I agree with everything that Paul said, and it's a compliment. Like, it's first what he said, and then there's a lot of people going in the train of Industry 4.0, and they don't understand what they're doing. They don't understand the book that Mr. Stefan already showed us. They don't understand. I have experience giving training to people. They simply don't understand the type of graphics they already have inside of their companies. They don't realize what's behind them. They don't realize the science, and they're sometimes making conclusions out of it. And sometimes they're putting in, I know one company, one IATF company, a big one, that's putting inside an Oracle SPC system. And I was giving training to people regarding things like this, and they were trying to build everything from the top. And Oracle was not helping them. They were adapting things. And I'm telling you this, they were having things like in the histogram. They were doing data, and I've shown them with their data that probably they're not talking about PPMs. They're probably talking about percentages, and because they simply don't understand, and they take data out of the process, and it's unbelievable. So they're trying to do capability studies and things like that without having
the fundamentals.
Some colleagues that said to me, Miguel, please think first. And thank you, Paul, for all of the answers, and Stephen.
Thank you for that summary, Miguel. That was really good. And you are actually now doing some training in Portugal. For people that want training in Portuguese, you actually put on some training classes in Portugal. Is that correct?
Yeah, sometimes I do like things like that. And I'm also helping International Lean Six Sigma Institute in certification, because I'm working and helping Miguel Araújo in Portugal.
Great.
So at this moment, we're trying to help people understand that, and helping companies understand the simple basics, like Mr. Paul said, because the lack of I think people like NASA stuff and space rocket science, and they forget about the basics.
Wait a minute. Wait a minute. I was a rocket scientist.
Sorry.
And all rocket scientists do is make simple things work properly all the time. It looks very spectacular when it all works, but that is all that rocket scientists do. I was a rocket scientist.
All right. And
I worked on the Galileo GPS system.
GPS, yeah, right. Brilliant.
Yeah.
Well, guys, it's been a pleasure having you for this hour. It was straight talk about process control. I hope people that have been watching this or watching it on YouTube will agree that we tried to keep to the basics and tell it straight about what process control is, how you can use statistical process control and real-time statistical process control to help your processes produce better quality, have better throughput, less downtime, and keep them the way they should be, the behavior, keep their behavior the way it should be, and not go out of control. This is the main point, I believe. You can contact me through ilssi.org. Paul Allen, again, thank you, Paul, with Allen and Partners. YouTube, Paul Allen, Six Sigma. You can find him on YouTube if you type in Paul Allen Six Sigma. Stephen Murphy, thank you, Stephen. Go to the Datalyzer.com website and get this free training there. There's there's some great videos showing Datalyzer in action at places like Coca Cola. And Miguel Ribiero, thank you so much for joining us, and thank you for the summary at the end. And good luck in Portugal with your training education of people to get these basics right. And Industry 4.0, try to tell those people what it is. Yeah, tell them what's real. Keep it real. Okay. So thank you. We're going to do this again. Straight talk with process control, Six Sigma. We might do one on design of experiments. Just watch this space. Watch us on LinkedIn. Thank you and goodbye.
Cheers, everybody.
Bye.
Cheers.
A pleasure. Thank you so much.